Imagine if you could inherit traits from your ancestors. Inheritance in programming is quite similar, and we will be exploring all about inheritance and its types in this video, so do watch it till the end. So what is inheritance and why it is essential? Inheritance is a mechanism that allows a new class to acquire properties and behaviors of an existing class. It fosters core reusability. Instead of reinventing the wheel, we can inherit from the existing classes, saving time and effort. Inheritance also promotes a clear hierarchy of classes, making our code more organized and easier to maintain. Let's head to the screen and see how we can implement it. So as you can see on the screen, we have created the car class with a constructor and a display method. So if I write obj is equal to car and pass brand as BMW and model as M5 and write obj dot and call the display method, I can see the brand and model printed as BMW and M5. Now let's create another class named Audi, and this will inherit from the car class, and inside this I will write pass. So the car class is the parent class, as this child class Audi is inheriting from the car class. So I will create a new object. I will write obj is equal to Audi, pass brand Audi, comma R8 as the model, and if I write obj dot, I can see the brand, model and display, which are attributes and methods of the parent class. So even if we don't have anything in our child class, it will inherit the attributes and methods of the parent class. Now let's give a constructor to the Audi class. I will write define init self comma brand comma model, and here I will write self.brand is equal to brand and self.model is equal to model, and then we will print this is Audi class, and here in the parents constructor I will print this is car class, so that we will know which of the constructor has been triggered. So now if I run it and create the object, it prints this is Audi class, and it also prints the brand and model, which is nothing but the display method of the parent class. So here we can see that constructor of the child class was triggered, but constructor of parent class was not triggered, and hence we can see this is Audi class is printed and this is car class was not printed. Now if I change the name of the attributes in the child class and run it, it will throw an error which says Audi object has no attribute brand, because in the display function, as we can see, it will print self.brand and self.model, which are the attributes of parent class. And since the constructor of parent class was never called, the attributes were never initialized, and hence we got an error. So when a child class has its own constructor, the constructor of parent class is never called and the attributes are never initialized. Let's create another child class. I write class BMW, inherit from car, and I will print this is BMW class and put it in a method named define BMW display, pass self. So now if I call the BMW display, it will print this is BMW class. So let's create a new object. I will write object2 is equal to BMW, pass the brand BMW, comma M5. It says this is a car class, which is there in the constructor method of the parent class, and our BMW class didn't contain any of the constructor, hence the constructor of parent class was triggered and it printed this is car class. Now if I write object2 dot brand, I can see it is BMW, which means I can access the parent's attributes. If I write object2 dot BMW display, now it will print this is BMW class. So this is how a child inherits from a parent class. A child can inherit the attributes and methods of the parent class only if they are public. Now let's make this brand as a private attribute. I will add double underscore before the brand to make it private and see if we can access it through the child class. Now if I run it, it throws me an error which says BMW object has no attribute brand. So a child class cannot access the private attributes or methods of a parent class. Now let's see how we can access the parents method inside our child class. So we'll try to access the display method, and to do it we use the super function. I will write super dot. Now I can see the display function of the parent class. So super always refers to the parent class. Let's make this brand again a public variable. And as I said, super will refer to the parent class, and now we can access this display function. So let's check it. If I run the object again, and now if I write obj2 dot, now the super function is inside our BMW display function. So I will write BMW display and run it. So I can see it has printed this is BMW class, and it has also called the display class which prints the brand and model. So this is how a child inherits from the parent class. Python offers several types of inheritance, each serving specific purposes. Let's explore a few prominent ones. Number 1. Single inheritance. In single inheritance, a class inherits from a single parent class. Second, multiple inheritance. In multiple inheritance, a class inherits from 2 or more parent classes. Third, multi-level inheritance. Multi-level inheritance involves creating a chain of classes where each class inherits from the one above it. Number 4. Hierarchical inheritance. In a hierarchical inheritance, multiple classes inherit from a single parent class. With inheritance, you are not just writing code, you are crafting relationships between the classes that lead to organized, efficient, and modular programs. We still have much more to cover in OOP, so stay tuned, and if you haven't watched the previous videos, here they are on your screen. Till then, keep learning and thanks for watching.